Ideal gas. Ideal gas versus real gas. Not much of a difference. When we talk about ideal gases are described to be gas molecules with negligible size. That means negligible size. Each gas molecule doesn't really occupy a certain volume. That's how small individual gas molecules are, with an average molar kinetic energy that's solely dependent on its average kinetic energy. And these gases interact only during an elastic collision. When we say elastic, there's no loss of kinetic energy. And take note, when we speak about ideal gases do not have any molecular interaction with each other, just when they collide either to each other or to the walls of the container. So when we talk about walls of the container, we speak about the measurement of pressure of these gases that they exert on these walls. So many gases are close enough to be an ideal gas because most of the conditions are usually at room temperature and at atmospheric pressure, which is usually 1 atmosphere. So for ideal gas law, one equation that's very common and we follow is the PV is equal to nRT. P stands for pressure, V for volume, N for the amount of gas expressed in mole unit, T for temperature, which must be expressed in Kelvin, and of course in every equation you should have a gas constant, the big letter R. The gas constant has a value of 0.0821 liter atmosphere per mole Kelvin. That R has to be memorized, and R dictates the units of the other variables. So therefore, liter has to be the unit of volume, ATM has to be the unit of pressure, mole has to be the unit of N, and Kelvin the unit of T. So PV is equal to nRT. These are the variables that you need to remember and the units that you need to follow every time you're dealing or using this particular law. And the different derivations for ideal gas law are these. You may be asked to get for pressure, volume, amount in moles, which you can extend to mass using molar mass, and of course temperature, in which when you're using this derivation, the default units follow the required units for ideal gas law. So how do we now use the PV is equal to nRT, in which we can insert the density and molar mass variable? I'm going to show to you now how we're going to derive a certain ideal gas law equation that's expressed in terms of density and molar mass. So let's start with looking into N, the number of moles. You know that from our previous calculations, when we talk about mole, you get mole by dividing your mass, which is small letter m, by the molar mass, which we will express as two big M's, or M and M. So small m stands for the mass, which is usually has a unit of gram, and molar mass, which has the unit of grams per mole. So when you divide the two, you'll be able to cancel out gram and you get the mole. That's why the formula to get N is mass over molar mass. So when we substitute this to the equation, it's going to be P times V is equal to M over molar mass, which we will enclose because that's for N, times R times T. And when we manipulate this equation further, when we want to put the molar mass on the other side, because it's in the denominator, you cross multiply that, this is going to be PV times molar mass is equal to MRT. And because our goal is to get density, and density is mass over volume, so therefore, if we want to transfer volume on the other side, so that we can get mass over volume expression, volume will cancel out there. So this is going to become P times molar mass is equal to mRT over V, in which if you look at mass over volume, that is the expression for density. So this is going to become P times molar mass is equal to density times R times T. And if you want to get density, of course, you just want to divide both sides by RT. So our final expression for density is density in terms of ideal gas law is equal to pressure times molar mass over the gas constant times temperature. So basically, that is the final mathematical equation in getting density from your other variables related to gases. So this is one of the formulas that you need to memorize for ideal gas law with density. And of course, if this is your basic formula, you can get molar mass from this. You just cross multiply that. And in terms of molar mass, if I may just write that down, so molar mass will become d RT over P. That can be a sample derivation for molar mass. So that's it for now. This has been Madam Narca saying don't stop learning, unlearning, and relearning. Please like, subscribe, and share to my YouTube channel. Bye for now. Thank you and God bless you.